Okay, so let's look at number 10. The forces shown on the object in the diagram cause it to accelerate. Okay, by accelerate, we mean move, speed up in that direction. In which direction will it accelerate? It's going to accelerate in the direction of the biggest force. So we have to see which direction the biggest amount of force is acting in. Okay, so very quickly, if we look at the vertical forces, we have 10 up and 4 plus 6 down, which is equal to 10. So those two will cancel each other out. So we have no motion in the vertical direction. Let's check out the horizontal forces. We have 9 newtons to the left, and we have 5.5 plus 3, which is 8 newtons to the right. Okay, so sometimes it might be easy to look at it like this. All right, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9 units of force to the left, and 1, 2, 3, 4, 5, 6, 7, 8 units of force to the right. Okay, so what we're looking for is unbalanced force. Okay, so if I go and I cross out 1 to the left for every 1 to the right, I'm going to find that I have 1 left over in this direction, the left direction. Okay, 1 newton left over, 1 newton of unbalanced force. And so it's going to move in that direction. Okay, because every unit of force on this side is balanced or canceled out, like the top and the bottom canceled out by a unit of force on that side. So our answer is going to be 1 newton to the left. That's B. Left, right. All right, let's look at number 11. A timer records a time of 50 seconds for a runner in a 400-meter race. What is the runner's average speed? Okay, so we're looking for a relationship. We want to recall a relationship between time, distance, and average speed. Well, we know that one. That is speed is equal to distance over time. And when we work that out, we're going to get 400 meters over 50 seconds. Go ahead and plug that into your calculators. Or if you see it already, how many 50s in 400? Did you say 8? Good. All right. So that means that our answer is B, 50. Our answer is B, 8 meters per second. Okay. All right. Number 12. A crate weighing 1,000 newtons is pushed through a horizontal distance of 5 meters at a constant speed. If 2,000 joules of work is done in moving the crate, what force was used to push the crate? All right, so we want to find a relationship between force, that's our force, distance, and work. Okay? Now remember, the force in this is not the weight of the object. It's the applied force, the force that was applied to the object. Okay? All right, so we're going to need to manipulate this equation. force is going to be equal to work over distance. The work done was 2,000 joules all over the distance that we moved it through, 5 meters. Okay, and so our answer is, did you say 400? Good. 400 newtons. Okay, good. Why do heavy goods vehicles often have more than 2 rear wheels? Is it A, to provide a smaller force on each tire? B, to provide a larger force on each tire? C, to provide a larger area of tire contact with the road? Or D, to provide a higher pressure to improve grip? Okay. All right, so let's go through a process of ruling some of these out. Right off the bat, we're going to rule out D because that makes no sense. Okay. Higher pressure. Pressure depends on what? Force and area. Okay. Grip has nothing to do with pressure. It has more to do with the amount of friction between the tires and the ground. Okay. So having more rear wheels is not going to do anything to that if we don't change any other variable. Okay. Changing the amount of force. More wheels. Changing the amount of force on the tire. That's a no. Okay. Because the amount of force depends on the mass of the vehicle. And that hasn't changed. Okay. So those two are out. What having more than 2 rear wheels does is it allows the force to be spread over a larger area, which decreases the pressure. Okay, so that's our answer, C. Okay, so you have to know the other part of that. Why do we want a larger area of tire contact with the road? We want to decrease the amount of pressure. Okay, so we don't get potholes and we don't get stuck. So that is what's going on there. Q14. Again, more pressure. Talking about pressure again. A man measures the air pressure in his car tires before starting a long journey. At the end of his trip, he found the tire pressures to be greater than at the start of the journey. What has caused this increase in pressure? Okay, let's think about that. Increases in pressure happen when air molecules collide more. Okay? Okay. So if the size of the tire didn't change, then we must be having more collisions. Okay, size of the tire, we didn't put air in it, so there's no increase in the number of air molecules. Increasing the volume would actually have the opposite effect. That would not increase the pressure because if they have more space, then they would collide less frequently. So D is out. Expansion of air molecules. Okay. No, air molecules don't expand in that sense. So what's happening is they're actually moving faster. Okay, more collisions. They're crashing into each other more. They're crashing into the sides of the container more. Okay, and that's because after a long journey, after driving for a long time, the tires, even if you go outside, if you touch the car tires after you have driven in the car for a long period of time, they feel hot, and that increase in pressure gives the air molecules more kinetic energy, and so that increase in temperature, gives them more kinetic energy, and so they collide faster and they push against the walls of the container more often. So our answer is A. Number 15, calculate the density of the 200-gram block shown. Use the equation density is equal to mass over volume. Okay. Just a warning, I know sometimes you guys get caught up in converting, especially when it comes to density equations. Do I need to convert from grams to kilograms? Do I need to convert from cubic centimeters to cubic meters? You do not, okay? As long as the units match, what I mean by that is if you're given grams and cubic centimeters, you're good. No need to convert, okay? If you are given kilograms and cubic meters, you're good. Now, if you're given grams and cubic meters or kilograms and cubic centimeters, then you're going to need to convert those. Okay? So just check your units before, but usually, you won't be given a question that'll try to trip you up like that. Okay? All right, calculate the density of the 200-gram block shown. Use the equation density is equal to mass over volume. Okay? So isn't that nice? They gave us the formula. So all we need to do is identify our quantities. So 200 grams, well, that's our mass. And our volume, so here's the trick here. We have to calculate the volume. We have to use one of those math equations that we know. This is a cube. So we have to find the volume. This is not a cube. Sorry, this is a rectangular prism. We have to calculate the volume, and the volume of a rectangular prism, which a cube is a special type of, is length times width times height. Okay, so 10 times 5 multiplied by 5 is going to give us, plug that in your calculator and you tell me what you get. Did you say 250? Good. Okay, 250 cubic centimeters. Okay, so now we're going to take that and plug it into this formula along with the mass that we were given. So density is equal to mass over volume. The mass is 200 grams and our volume is 250 cubic centimeters. Plug that in your calculator and we're going to find that our density is 0.8 grams per cubic centimeters. There it is. That's A. All right.